welcome to Free Coding Academy's Unit 9 review video for Computer Science A. Unit 9 is called Inheritance. Topic 9.1 is also called Inheritance. So class hierarchy organizes related classes by grouping shared features into a single superclass. Subclasses inherit attributes and methods from the superclass. So, for example, you might have a superclass called dessert, and then subclasses might be cookie or biscuit or cake. So, biscuit, cookie, and cake are all subclasses of superclass of dessert because they are all desserts, but they're each unique as well. So the extends keyword creates subclasses which inherit characteristics of the superclass they are extending. So the subclasses are going to inherit certain things from the superclass. So a subclass can only extend one superclass. So when a subclass extends a superclass, it forms an is-a relationship, meaning the subclass is a special version of the superclass. So for example, a brownie subclass may extend a dessert superclass. Thus, the brownie is a dessert. However, we cannot say that a dessert is a brownie, therefore inheritance only goes one way. The superclass or parent class does not inherit anything from its child or subclasses. Next, topic 9.2, writing constructors or subclasses. So subclasses can't directly access private instance variables from their superclass. Constructors aren't inherited by subclasses. So a subclass constructor must call the superclass constructor as its first line using super with suitable arguments. So you can pass in parameters if you'd like into super, or you could just use empty parentheses if it's just a default constructor that you want to use. If super is not called, Java automatically inserts a no argument or default call to the super constructor. So parameters in the super constructor call are used by the superclass constructor to set up instance variables for objects of the subclass. So the chain of constructor calls continues up the inheritance hierarchy until the base object class constructor runs first. Each constructor in the hierarchy then executes in order from top to bottom. Topic 9.3, overriding methods. So method overriding happens when a subclass defines a public method with the same name and signature as one in its superclass. So a method must be declared in either the current class or inherited from a superclass to be usable. Subclasses often customize behavior by overriding methods, adding new methods, and having extra instance variables. So all public methods from a superclass, such as getters and setters, are inherited and stay public within the subclass. Method overloading refers to using the same method name in one class, but changing the parameter list, so either the types of parameters, the order, or the count, to distinguish between them. So this is an example. So this is the superclass book method. So public string read book, int num pages, return read plus num pages plus pages of the book. So this is a method in the superclass called book. So it has a readBook method which takes in the number of pages as a parameter, and then it returns a string saying how many pages you read. Next, this is a subclass called fictional book, and this is the readBook method which is overridden inside this subclass. So in this overridden method in fictional book, it takes in the name as a parameter as well as the number of pages, and then it returns a string that tells you how many pages you read of a certain book with a certain name. Next, topic 9.4, the super keyword. The keyword super allows a subclass to access instance variables and methods of its superclass. So it can be used to call a superclass constructor within a subclass constructor, usually as the first line. It can also be used to call a method from the superclass by writing super.methodName and passing the necessary arguments. Topic 9.5, creating references using inheritance hierarchies. So Java's class inheritance hierarchy starts with object at the top. all classes eventually inherit from it. If class S is a subclass of class T, then T is the superclass and S is a special type that is a T. So polymorphism refers to when a variable of type T can refer to either a T object or any subclass object like S. So this is best illustrated using an example. So for example, if animal is the superclass and panda is the subclass, then the variable declared as an animal can be initialized as an animal or as a panda because a panda is both a panda and an animal. So here is another example. So animal hippo is equal to new animal. This is valid. Animal grizzly is equal to new panda. This is also valid because a panda is an animal. However, panda bear is equal to new animal is not valid because an animal is not a panda. Next, declaring variables, method parameters, or array list using the superclass type T allows you to work with any subclass of T in the same structure. So, for example, array lists can only hold one object type. So, if an array list called zoo is initialized to hold objects of the superclass type T, then all the subclasses of animal can also be held inside the array list. So if the array list is initialized so it can hold all objects of an animal type, then it can hold objects that are pandas, or if you have other subclasses to animals such as koala, kangaroo, etc. All of them can be held within the single array list because all of those different objects, those subclasses, are also animals. That's polymorphism. Next, topic 9.6, polymorphism again. So polymorphism is when an object has both a declared type, a compile time type, and an actual type called a runtime type. So in the past example, for instance, we had animal, and then let's call it grizzly is equal to new panda, right? So the panda is an animal, but it's also a panda, right? Therefore, the declared type in that case would have been an animal, and the actual type would have been a panda. So at compile time, the Java compiler checks whether the declared type contains the non-static method being called. If not, there will be an error. So basically, when you have an object that exhibits behaviors of polymorphism, so it's declared as one type and then initialized as another type, when you're calling a method on that object, first, the compiler is going to check if that method exists within the declared type. So in that case, if animal contains that specific method. So if it does not, then there's going to be an error. So when you have an object like this, like an example, you cannot call methods on that object which only exist within the panda class and do not exist within the animal class. If, however, it exists within the animal class, then it works. And if it exists within the animal class, but it's overridden in the panda class, then the method in the panda class will be run, and in that case, it also works. So at runtime, if the non-static method called previously is overridden in the actual type, then the overridden method will be executed instead of the declared type. But the method must exist in the declared type in order for this kind of object to be able to call it at all. So for static methods, only the declared type is used to determine what method to execute. Topic 9.7, Object Superclass. So the object class is the top level superclass in Java, of which all other classes are subclasses. So these are some common methods from the object class. So first we have the .toString method, and it's used to convert an object to an informative string. And if you recall from before, most classes will choose to override this method with their own because they can provide a much more informative string as opposed to just the default version that just gives you the memory address. The other one is the equals method, and again, most classes will choose to override this one by checking whether two objects contain the same attributes or not, as opposed to the default method, which cannot accurately assess whether the actual attributes match or not because the object class is not specific to whatever object you are referring to. So it's used to compare two objects for logical equality, so checking whether their attributes are the same. So if you use two equal signs to compare two objects, that's only going to compare whether they both reference the same location in memory and are therefore the same object. Next, using Boolean equals object other, the equals method from before, to compare ensures that actual values and data are being compared between two objects, so attributes, like we said before. So subclasses usually override the toString and equals method, as we mentioned before, to provide behavior specific to their own class. And that's it. Thank you so much for watching, and be sure to check out the video reviewing Unit 10, the final unit, next.